Well, here we are at the test bed for my projects. So here we have my project, which took a little bit to put together. I started off with a Hello World application, which is just a button with a resistor, and light up the LED. Make sure everything's wired up correctly. And the next thing that I'm going to do is load up my Theremin Arduino thing. And uploading. Done uploading. Now as you can
in a particular pair of Wiimotes. So, for example, if you're all standing still and if you move this Wiimote energetically, then you start seeing things on these two panels. So if you stand over here, you will be looking at the two panels that are representing your relationship to the other two balls. So now if you stop shaking and you start shaking, so we're seeing things on this panel. So you should actually stand here. And then if you stand here, and then you stand here. So now if you start doing similar patterns with your Wiimotes, you'll see things. So for example, if you just start doing something that's similar, you start. Oh, just by the way, so if you're all standing, if you're all still, you're very similar. So to kind of break it up, if you do the circles like you have them. So now because of maybe stronger circles. This is also a workout system. so the particular patterns of similarity and dissimilarity are what flow down each of the panels. That's between each pair of the objects. And certain things in the movement are also in the audio.
Now we have percussion suddenly.
So if you're all doing the same movement, the percussion should come in.
Go.
Open your mind.
understanding, a Markov chain or process is a sequence of events or states. Each of the states is dependent only on the event immediately prior. A hidden Markov model then represents the random sequences evidenced by observations. So it's a dynamic, usually time-based model, and is statistically dependent upon the Gaussian density from which the observation is taken. So the HMMs for this system would be ergodic, and emission and transition probabilities would need to be calculated after making observations with a few users. The NeuroSky company has defined the optimal attention and meditation states with the mindset EEG, and it would be interesting to observe what types of skin conductance levels, our heart rate values, would correlate with these states. I don't imagine there would be a direct one-to-one correlation every time, and so a grid of states and relationships would have to be generated, and this would be determined by making the user perform certain tasks, such as something in the real world like building a puzzle, or have them play computer-based games that are specifically designed to either force them to pay attention or to make them space out somehow. It would be interesting to also eventually try and classify and create models for emotions: happiness, fear, excitement, laughter, sadness, anxiety, etc. Perhaps we could even tie in Isaac's system of emotion states and correlating images on the internet and have them interface with his system while wearing my sensors. So my system itself could be used with other systems that are using some sort of audiovisual design or media. So eventually, entrainment of some sort could be introduced for therapeutic, recreational, or game settings. But the purpose of this video is just to propose a system where pattern analysis techniques could be used to capture multimodal data using these finger biosensors via USB to the computer with the graphing software, and that's for heart rate variability and skin conductance levels, and simultaneously capturing brainwave activity with the NeuroSky mindset. This could be done offline or eventually in real time. Realistically, the data would be taken and then it would be analyzed offline.